Hello, I'm Emily, and today we're going to work on a unit conversion problem. You might think it's trivial, but unit conversions are actually really important in chemistry. In this problem, we're asked to convert 5 grams per milliliter into units of kilograms per microliters. So the way I like to set up these problems is to start off with our 5 grams per 1 milliliter. The next step is to determine how grams and milliliters are equivalent to kilograms and microliters. We know that 1 kilogram has 1,000 grams in it. So in order to get rid of grams and have kilograms in our final answer, I'm going to put 1,000 grams on the bottom and 1 kilogram on the top. This way our gram units cancel out. Next step is to determine how milliliters are related to microliters. Which one is smaller? Microliters are smaller. And we know that there is 1,000 microliters in 1 milliliter. So 1,000 microliter in 1 milliliter. Now these units cancel out. And we are left with 5 divided by 1,000 divided by 1,000. And that's just going to be 5 times 10 to the negative 6 kilograms per microliters. And this is our final answer. The next problem that we're going to work on is identifying the number of neutrons, protons, and electrons in an atom. Let's look at this carbon-13. So the easiest one to figure out is the number of protons. The number of protons is what determines what elements we have. So if we have carbon, we know that we're always going to have 6 protons no matter what, because it's carbon. And it's defined by having 6 protons. Now if we look at this, we see that it is a neutral atom. So in order for it to be neutral, it has to have the same number of protons as it has, the same number of electrons as it has protons. So if it has 6 protons, it's going to have 6 electrons as well in order to be neutral. Now for the number of neutrons, this 13 up here is the mass number. It is the number of neutrons plus the number of protons. So if we know that we have 6 protons, we can simply subtract 6 from 13 and get 7 for the number of neutrons.